Okay, so here's another functions question. This time you want to find the coordinate of the points of intersections of, we've got a quadratic function and a linear function. And remember here that there's three possibilities. The first one is that the line goes through and you get 2 points of intersection. The second possibility is that the line simply touches and there's 1 point of intersection. And of course, remember, you can also get this case here where there's no points of intersection. Okay, now you can do this manually, but by far the easiest way to do this is to do it graphically on your calculator. So that's what I'm going to do. Okay, so we need to enter both equations into our calculator. So I press y equals, and it doesn't matter which order, I'm going to do them in the same order that they're written. So x squared plus 6x plus 5, enter, and 2 divided by 3x plus 2, enter. It is important that you enter both times. Okay, and then we just go to graph and make sure that we can see what's happening. Now, I can clearly see my quadratic and my linear function, and I can see both points of intersection. There's 2, but what I'm going to do is just show you the technique. I'm going to zoom in on this area here so we can see it a little bit easier. So I'm going to hit my zoom button, and it's called zoom box. So I'm just going to hit enter to select one. And what I need to do is I want to move my cursor with my arrow key. So I want to get to the right top corner of where I want my new screen to be. So I'm going to move this slowly and steadily across my screen. You can do this faster on your calculators. So something like that. It's probably far enough to the left, and I'm going to move it up because I want to get both points of intersection in, and that's probably a pretty good point for me to start drawing my box. Once I've got that cursor in position, I hit enter, and it changes to a square. Now I'm going to use my arrow keys again, and I'm going to draw out the shape of my box. So I'm going to come across on the right here until I've gone far enough to get the second point of intersection. So I'm going to come just slightly past the y-axis to about there, and now I'm going to hit the down arrows, and here you can see how this works. You can see my box taking shape. Okay, and I just need to get this clearly. That's probably good enough. I don't need my vertex for solving this equation. So once I've got the box drawn, the shape I want, I just hit enter, and then the calculator redraws that part that was inside the box. It draws it as the whole screen. So now we can really clearly see our points of intersection. We could have done this without that, but I wanted to show you how to do that zoom boxing. Okay, so we're looking for a point of intersection. So we go second calc, and we're looking for number 5, intersect. So choose 5. Okay, now we need to find our cursor. I have no idea where it is, so I'm just going to move it along here until I can actually see it. Ah, there we go. I thought I saw it there. Still can't. There we are. Right. Now, can you see? It's been sitting on my quadratic curve, and so here it is here. Now, all that's important here is that my cursor is relatively close to the point of intersection. It doesn't have to be as close as this. And I have to make sure that I have y1 up here. When it says first curve, I need y1 up here. So that's okay, I'm going to hit enter. Then it asks, is this the second curve? So it's actually jumped lines, it's a bit hard to tell. So it's asked the second curve. You need to check up here that says y2. So you can hit enter. It wants you to guess, just hit enter one more time. And there's the point of intersection. So we're going to write this down. X is negative 4.69. So our first one is negative 4.69. And let's look at the second one. It's negative 1.13. Negative 1.13. Okay, there's our first point of intersection. And now we need to find the second point of intersection. Okay, so we have to go back to our menu and start all over again. So second, calc, intersect. Okay, now see where our cursor is. It's sitting now on exactly the intersection point that we found before. But we need it to be at this intersection. So we have to move the cursor here so that it's going to find this intersection and not just tell us this one again. So I'm going to use my right arrow and just patiently wait for my cursor to come around until it's much closer to the second point of intersection than it is to the first. It doesn't have to be straight on top of it, but you do want it to be much, much closer to the second point of intersection than it was to the first, or otherwise you're just going to get the same answer again. Okay, now remember what we're looking for. The calculator asks, is this the first curve? You look to see that it says y1 up here, and then you can hit enter. Then it asks if it's on the second curve. You look to see that it says y2, and hit enter. It wants you to guess. You just hit enter one more time. And here, clearly we're on our second point of intersection, and there's our solution. So the second coordinate is x is equal to negative 0.639, negative 0.639, and the y value of the coordinate is 1.57. Okay, so there's our answers, but really you should draw a sketch to show how you found this, because there's no working on the page here. So you really want to draw a sketch that's relatively accurate for what you see. So this is what you want to do. You want to really try and draw the graph as you see it there. So draw your axes in. Try and draw your quadratic curve about right. You can see it's going through negative 1, negative 2, negative 3, negative 4, negative 5. So negative 1, negative 2, negative 3, negative 4, negative 5. The graph comes like that. And the linear function goes through 3 and 2. So it goes through like that. It's not a very straight line. And here you would write your coordinates of your points of the intersection. So negative 4.69, negative 1.13, and up here you'd write the second one, negative 0.639, 1.57. Okay, and then you've at least shown how you found your answer.